Good evening, everybody. My name's Chris Gregg, Director of the UQ Energy Initiative and the Dow Centre for Sustainable Engineering Innovation at the University of Queensland. And tonight I'd like to welcome you to our first UQ Energy Express seminar for 2016. Tonight's event is being co-hosted with the Grattan Institute from Melbourne and the Global Change Institute. And so we're really pleased to have those two partners involved in the event. Most importantly, though, I think a great way to kick off 2016 with Professor Robert Socolow, co-founder and co-director of the Carbon Mitigation Initiative at Princeton University. Rob has been one of the original people pioneering efforts in environmental physics and how we deal with those twin challenges of supplying energy and meeting economic growth while looking after the environment and particularly avoiding carbon emissions. His work is highly acclaimed. It goes back for decades. I think everyone in the room will know about the very famous climate stabilisation wedges paper, which is, I think, 12 or 13 years old now, but still regarded as one of the sort of cornerstone pieces in this space. I don't think I should say much more, probably other than what I should say about safety. If there's a fire alarm, we'll look after you. Follow us out through the doors on the side here. If you need a bathroom, out through the back doors off to your left. But I think without any further ado, I'd like to welcome Rob to the stage. He's going to talk about truths we must tell ourselves if we are to address climate change, and we'll follow that with a panel discussion afterwards. So everyone, please welcome Rob Socolow.
Thank you, Chris. Well, greetings, everyone. It's a great pleasure to talk to you this evening. Climate change is one of the most interesting problems and most difficult problems humanity has ever faced. And tonight I'm going to give you some sense of some of the interesting questions that are at the edges of climate change and managing climate change. And I hope you find them interesting. I call them truths we must tell ourselves. We're very good at making things look, at confusing ourselves and deceiving ourselves. Let's see if what we need to actually know. So there's one very big idea, and it's such an unfamiliar idea that I want to discuss it in some considerable detail. And that is that human activity on the planet is large enough to change the planet. This has not been true before in any significant fashion in the history of humankind, so we're struggling with it. The world's forests, many of them already gone and being replaced, the world's fisheries, finding all the low-cost oil and now going on to less valuable hydrocarbons, changing the concentration of carbon dioxide in the atmosphere already by about 40% compared to what it had been during most of the period of development of human civilization. A new word being coined which has a geological feel, the Anthropocene, as opposed to the Eocene or the Miocene or the Pleistocene, referring to the fact that we are in charge of the planet's structure for the first time. The word is being explored, developed by social scientists and philosophers and so forth. Question, when did it begin? No obvious answer, no exact answer. Perhaps with nuclear weapons, perhaps with a steam engine, perhaps with carbon dioxide crossing 400 parts per million. You could decide it in various ways. And critical for the story that we're living with is that we don't like the message. This is not something we're happy about. We would just as soon live on a much larger planet, like Jupiter, where we've been emitting CO2, and it would make very little difference, where there were so many forests that we couldn't get through all of them for a very much longer time. So what happens when you send something unfamiliar to people? They don't like it. They reject it. They shoot the messenger. I can think of two prior experiences where science brought messages to the average person, to the society as a whole, that were not welcome at all. and that are familiar that have characteristics in common with the climate change problem. Galileo, at 1610, takes his telescope, looks up. There'd been telescopes around, but no one else had looked up. And he sees the moons of the phases of Venus, the moons of Jupiter. He says, "Look, we're in a planetary system, and we're not the center of it all." And people look in his telescope, and they have to agree. But it doesn't sit very well. It doesn't sit very well. We really want to be the center of things, so people want it not to be true. He gets excommunicated. He's an older guy, and by the time this happens, he's had a pretty good run before it happened. He's obstreperous. But he encounters tremendous social resistance. Darwin comes along 200 years later, 40, 50 years later, and he has a new message. He's been studying the animals and the plants and sees curiosities and says, there's a common mechanism here in which there's specialization and species selection, and we are part of that. And the public press calls him the monkey man. And they don't like it. The public doesn't like it. And to this day, that way of looking at the development of life is resisted. In my country, there's been a history of this which hasn't ended. So I say the idea that human beings can change our planet is as out of date and wrong as the Earth-centered universe and the separate creation of man. But all three ideas have such appeal that they will fade only very slowly. So I think when we say, why aren't we moving faster with climate change, reacting to climate change? I think this is an underlying reason. We don't want it to be true, so we fight the message. My country has one of the major political parties is Exhibit A of all of that. And what is the message? It's a very complicated message, among other in terms of how we think about ourselves and the human condition. So this is a figure coming from Princeton is blessed with having one of the major climate modeling centers of the U.S. government in the same town, called the Geophysical Fluid Dynamics Laboratory, perhaps the worst name for an institution. And this gives a sense. The drawing is rather straightforward. You have a topological map. You can do this for any part of any seacoast. This maps have been drawn for almost every seacoast. Probably something like that exists for Queensland. And this is what happens to Florida. And I'm not sure all of you know what you're looking at there, but that's Florida and the Gulf of Mexico. There's Louisiana, where a lot of the natural gas is developed offshore. That's the Appalachian Mountains. And sea level rise of 1, 2, 4, and 8 meters are altogether different. And by 8 meters, much of southern Florida, which includes Miami and Palm Beach, is gone. Because it's very, very low land. The hills are 10 or 5 meters high in South Florida. So we look at that. And then we say, well, what kind of sea level rise is plausible? And it's pretty straightforward to figure out how much ice is in various ice formations, and then to think about how much sea level would rise if that three-dimensional structure became a thin cap of water. And both the Greenland ice sheet, which is more than a couple of kilometers thick at its thickest, and a small portion of the Antarctica, which is called the West Antarctica ice sheet, have roughly the same amount of CO2, of ice in them, which would correspond to the 8-meter picture. So the next question is, well, is that going to happen? Well, the argument is we don't know, but it's plausible that it will happen. There have been sea level rise changes of 100 meters between ice ages. Very inconvenient to us. And we don't know how fast. But a number comes out of the IPCC reports of something like, think about 1 meter per century of sea level rise for several centuries. And then acknowledge that we're not at all sure of that number. But if you get that in, you get started. So that raises questions that of the kind that I don't think are posed very often. How much should we care that sea level rise is going to flood South Florida and many, many other communities? What are our obligations to a future generation? These are different kinds of obligations any human beings have dealt with before, as far as I can understand it. Does it matter how capable they are? One of the arguments out there is people are getting smarter and richer, and they'll be able to handle whatever that is. What if are they going to be so completely different from us in their preferences that we can't guess how hard we should work? But they might be less capable. We might have been inflicting other injuries on them in various ways. They may have gone into a kind of a dark ages for reasons we can't imagine. And then we would have, does that change our obligation? And what about 5 meters in 2500 versus 1 meter in 2100? Are they equally important consequences? We tend to blur this issue of what is actually being done by our creating climate change. This is a good one to think about. Many of the others are shorter term, greater heat, more drastic heat waves, more frequent storms. They, I think, are in a different category as to how to decide how hard to work to mitigate these kinds of consequences. Let me talk about the international dimension of climate change, which is very important, rather difficult to whoops, sorry. I'm sorry, no, that is the next one. That map at the top is showing carbon dioxide emissions by country with circles whose area is proportional to the country. It's a few years ago. China and the U.S. stand out, blue and red. I've put a little red circle around Australia for tonight. And it's blue because it's in Asia. I guess it's not clear how exactly. I guess it's by continent. Most of the discussion of climate change has been at the international level has been about per capita data for countries. The U.S. per capita emissions are almost 20 tons of CO2 per person per year. Australia's number is quite similar, as I recall. The European average is about 10. China's been moving from 3 to 6 to 8 to around 10, I think, now. India's maybe 2. But the conversation is about countries. And what I write here is that I want to tell you some work that I was involved with that really says countries are an inadequate way of looking at the problem. There's enormous diversity of emissions within countries. And so suppose you could have a way of figuring out how your emissions and your emissions, everyone here has a certain emissions on the order of 5, 10, 15, 20 billion tons of carbon dioxide per person, such that you add them all up, and that's the global emissions, which are roughly 40 billion tons of CO2 per year. Suppose we had such a method. We would have inequalities within countries represented by different numbers within countries. And then we just forgot which country people came from, and we just sorted them out by smallest to largest. If you do that, you create an interesting curve. And the way we did that was to look at income distributions and do some kind of a relationship between income and emissions, looking at the carbon intensities of individual countries. So if a country like Norway is mostly hydro, then even though you're living a happy lifestyle, you've got not that large emissions. So you make those kinds of corrections. And out comes some data. I'll show you a couple of results that suggest that there's about 1 billion high emitters in the world. Our paper was called 1 billion high emitters. When high is defined to be more than about 10 tons of carbon dioxide per person per year, and that about half of those, but a growing fraction that's going to pass half, are not in the OECD, which is the Europe, US, Australia, Japan, New Zealand set of countries that's the Organization for Economic Cooperation and Development, and more than half by 2030, less than half by 23, which is when the first data point was, and maybe about half right now, are in the developing world. That's a rather important fact, because you have this international argument for now 2 decades, where the developing countries say, look at our per capita emissions. They're 1/5 of those in the developed world. The developed world says, look at your total emissions. They're 1/2 of the total. And you just talk right past each other. What's finally going on is getting past that level of conversation. There was a major meeting in Paris, as many of you know, last September, leading to, for the first time, an agreement that we are really all in the same boat. We have a comparable set of obligations. Not having that view of the problem for 20 years really impeded progress. And the other part of the story is that the lowest half of the world's emitters, that's roughly 4 billion people, altogether created emissions of the order of 8% of the total. So let me show you another graph of this, making the same point, a little bit complicated. But we arbitrarily bin the emitters, you and me and our friends, and people we don't know by 3 to 4 to 5 degrees of separation, into 3 bins, more than 10 tons of carbon dioxide per person per year, the average European, 2 to 10, and below 2. 3 bins of emitters. And those bars are segmented horizontally because it's emissions by 23, and then the additional emissions between 23 and 2030, according to projections of where the world is likely to go. It's interesting that the world's projections of carbon emissions growth don't differ very much from projection to projection. People think Asia is going to keep building up its emissions. The Europeans and Americans are going to kind of hold the line. We're at roughly where they are. But almost all Australians are in the top bin. Not all of them, but most of them. And you see the facts that I just described there. It's worth noting that bottom bin, that more human beings will be in the lower bin in 2030 than in 2003 by these calculations. If you like, that's poverty. And more people will be poor because there's more people altogether. The growth there is from 6.2 to, let me just check for it. Yes, 6.2 to 8.2 billion people in that time period, 2 extra billion. And all 3 groups get bigger. It's not the case that we are reducing the number of people whose emissions are below 2 tons of CO2 per person, but rather it's getting bigger. And when we talk about the lower emitters, we have the problems of poverty. I should say that if you start back to that, if you take that 2 billion people with emissions below 2 and you double their emissions, it's not since it's only 8% of the total emissions, it's not a major change. It's an 8% change in the total emissions. If they were to have twice the emissions they do right now, 4 billion people. The very poorest people emit so little that even though they're half the world's population, increasing their use of fossil fuels as they move out of poverty is a small effect on global emissions. And that applies to other global measures as well, like oil consumption, for example. And the developing country poor, as opposed to the developing country middle class, have a whole set of energy issues, which some of you are working on, notably that the single largest public health connection to the energy system is through air pollution, roughly equally indoor air pollution in terms of deaths and outdoor air pollution. This picture shows over 1 million deaths per year from indoor air pollution from burning biomass, straw, dung, and twigs inside poorly ventilated homes. There's something like another 1 million deaths per year in outdoor air pollution related to power plants and steel mills and other things that are not controlling their emissions and creating very bad air outdoors. Mentioned briefly this issue about the fact that the political structure is called the Framework Convention, United Nations Framework Convention on Climate Change from 1992, from Rio, embedded a 2-tier structure for the world. One set of countries, roughly the OECD, included Russia, was given all the obligations. The rest of the world was allowed to pass. And that has finally changed. But it's interesting why that happened. What was the mentality? What has been the mentality? And I refer here to the fact that as I see it, this was the Framework Convention in 1992, and until about 3 months ago, was a post-colonial institution in which the underlying argument was from the colonized to the colonizers, you owe us something. You've got to get your house in order first. And the colonizers, former colonizers, saying, yes, we feel very guilty about that. You're right. That, I think, has come to a close, and I talk about post-colonial institutions, of which we are moving in that general direction. I hope these things I'm saying will challenge you, and you'll want to argue back. A word on population. I found in my years of talking about this subject that if I don't mention population, someone will ask a question that is essentially, where does population fit in? And I think I've tried to find one slide that I could talk about that stimulates me anyway to realize what kind of problem this is. The United Nations has a kind of monopoly on population projections. Everybody reads them and uses them. And the United Nations, I think this is the most recent one, but if it isn't, it's very close to the most recent one, suggests that in 2100 there's a 10 billion person difference in the population of the planet, depending on their high versus their low scenario, and the middle value, which as you see has the population stabilizing at about 10 billion people. 6 versus 16 is the difference between moms having 1/2 extra kid relative to stable populations, which is about 2.1 kids per mom, and versus 1/2 extra kid, 2.6 versus 1.6 kids per mom. You get a falling exponential versus a climbing exponential, which by 2100 has resulted in a 10 billion people difference. This is up to us. I say to young people sometimes, you're very interested in green objectives. You may want to bicycle more and buy green products, but probably the decision you will make that has the largest impact on the future of these kinds of areas is how many children you will have. That often surprises people. And 50 years ago, 40 years ago, when I was getting into this subject, population and environment were linked, deeply structurally linked. One of the major textbooks was called It's called Ecoscience: Population, Resources, Environment. It was all one problem. It got severed. There's a history of science thesis to be written on how that happened, why the environmental committee and the population arguments went in different directions. So that when I'm bringing it in here, I realize I'm doing something a little unconventional. But I'd like that graph as helping us think. And then if we extend the falling curve, which is dropping by 0.8% per year at the end of the century, for another century, we get to a global population of 2.8 billion people, and we go a couple of hundred years further, 500 years total, we get down to a population of 250 million people on the planet, just by having 1.6 children per mom on average. Is that something we actually are frightened about, would welcome? We haven't begun those conversations. The conversations of the previous 50 years till now have largely been about very large populations, women having far more children than they would like, parents having far more children than they would like, access to technologies that change that. That agenda is not finished, but it's largely finished. I think there's a new agenda that's embedded in the data that tell us that many of the wealthy countries of the world are below replacement level in populations right now. Japan, Russia, Italy, and not Australia as far as I know. Okay, so underlying all of this, the question of whether part of this entire story is thinking globally, having a planetary identity, and I ask you to consider, do you feel yourselves a planetary identity? You root for some team, you come from some village, you have some religion, you belong to an Australian state as well as the Australia as a country. And this whole subject, one of the reasons it's so difficult is we're being asked by the problem to develop another level of loyalty, another level of concern. So now let me turn to some of the solutions that are part of the problem. One of my views on the climate change problem is that there are no good solutions. Every solution can be done badly or well. And that everything depends, but many people don't think so. Many people are just convinced if we just bring on X, we'll be fine. We might bring on nuclear power. That was widely believed in the 60s and 70s. It was clearly the way to run a world and get out from under even the climate change problem that was already recognized. Many people feel that way about renewables. I don't want to detract from that, but I can envision, and most of you can envision, something going wrong if we're not vigilant. Conservation can bring excessive regimentation. Renewables are very land intensive. Clean coal, which is largely the idea of taking carbon dioxide out out of the exhaust of a coal power plant and putting it below ground so it never gets to the atmosphere bothers lots of people because they don't like the coal industry and the way it functions, especially if you realize that in each instance, we're not talking about what's going on in Australia, but what's going on in the world. Nuclear power does have its own connections to nuclear war, as the whole story of Iran over the last 9 months has demonstrated. And I'm going to talk a little bit in this event about geoengineering, some of which, that word that not everybody in the room probably has any feel for. But the overall message, I think, is that we must take into account both the risks of disruption from climate change and the risks of disruption from the solutions. It's not as if we have something to trade in for something much better without being vigilant in the process. And that we should think of this as an iterative process. The solutions themselves are unfamiliar, and we have to get to know them and modify them. And the seriousness of the problem is unfamiliar. So let me talk about a few of the solutions. Let's start with this picture is a picture from a Scientific American article that I wrote in 2005 called Can We Bury Global Warming? Chris Grigg, who introduced me as one of Australia's leaders in understanding the option of taking a coal power plant or a natural gas power plant or a biomass gas power plant, more or less as it's running, and intervening to take the CO2 out of the exhaust stream. You've already got your energy out when you've made your CO2. Where you put your CO2 is a separate decision. We use the atmosphere as a garbage pail. We don't have to use the CO2 as a garbage pail. Am I speaking loud enough that people hear me in the back? I should talk louder. Well, please say so. Okay, so I hope I haven't lost you entirely. My voice has been low. I can pick it up. So this is a story of trying to figure out how much carbon dioxide below ground goes with a 1,000-megawatt power plant, the typical large coal power plant, and to realize that there's a very large volume below ground is required to go with a power plant that you build above ground to put the CO2 in. There's much you could have an entire course on how to think about this option. Needless to say, it's been very difficult to get people to buy into this option as one of the ways of dealing with climate change. The environmentalists see this as a way of prolonging the life of coal. They don't want to give coal industry any help. The coal industry sees this as a way of paying extra for carbon dioxide for a problem that they don't really want to acknowledge in the first place. So it doesn't have many friends. And yet, how warmly we receive, how intelligently we receive this option rather than dismissing it is an index, I think, of how strongly we care about climate change. Is my voice up now enough, or do you still have it up? Still up, okay. Quite a number of the issues that deal with climate change involve using the biosphere, what's growing on the land. There's roughly as many carbon atoms in green plants on the surface of the Earth as in the atmosphere. So a few percent change in the carbon dioxide and the carbon content. Good, Chris. That's a little too much. A few percent change in the carbon content of the biosphere, up for the biosphere, down for the atmosphere, if you have an exchange of that sort. So growing more trees reduces the carbon dioxide concentration of the atmosphere. It involves a lot of land to make a significant change in the atmospheric CO2. Yet, some of the solutions that are getting a lot of attention are biology-based. And I list 4 of them there. Displace oil with fuels like alcohol made from the things that grow. You have to grow a lot of stuff on a lot of acres of land. The yield matters, obviously. That means how much you get from the land. Or make electricity instead of, and push coal out of the economy to some extent. You can do all of these things. The answers that you should insist upon are answers in hectares. How many hectares of land do we need to use to get a given amount of displacement? There are 2 more on that list which go into the category called negative carbon, which plays it was beginning to play a major role in the way people are talking about the climate problem. plays a much larger role, played a larger role in the most recent report from the IPCC, this meeting in Paris of last September, called Conference of the Parties 21, or COP21, made much of the importance of negative carbon so that we can undo some of our mischief down the road, later in this century, for example. And two ways of doing that are to, for example, take biomass, vegetable matter, trees, crops, dedicated crops of one kind or another, make electricity, capture the carbon dioxide, and put it below ground. If you think of what's happened to the carbon atom, it came out of the atmosphere in photosynthesis, went below ground, so we've scrubbed the atmosphere. So too would be increasing the carbon stock, as I mentioned before, by growing additional trees or putting more carbon in soil and things of that sort. So biomass has a potential to alleviate the climate problem, but it has a potential to make major differences to the way in which we use land, which we may not really want to see. And solving the atmosphere's problems while changing the planet's surface is maybe a bad trade in certain circumstances. It certainly would be. So consider this. So I think the underlying word for all of these issues of making the solutions better, more salubrious, is the word conditionality. So consider yourself a forester or an agronomist in a world where the carbon price is very high. You're working for someone, maybe a forest management company or a forestry service in a government, and you're told that storing carbon is your only objective. What would you do? The more any of you in the room knows about forestry or agriculture, the more creative and full you'll give as an answer. But you've got an objective and you're out to please the boss. Might be a country, might be a company. And you do things which you might actually have qualms about yourself if you took further objectives in hand, but you do them. At least you write a report recommending this, that, or the other thing. Now change roles. Be the policymaker who considers this playing itself out, who has in fact written a policy asking only for carbon storage or asking for carbon storage and in addition attention to biodiversity, attention to the water system and other things. How would you modify the rule, write the policy in the first place in such a way that you were eliciting the behaviors you wanted and not the behaviors you didn't? This is my example of what I think applies to almost all the solutions. And we're nowhere near paying enough attention to how solutions to climate change will be implemented. And that has to be part of the story going forward. It's one of the truths we need to tell ourselves. Some words on geoengineering. I'm curious, how many of you have not heard the word geoengineering or have very little idea of what it's about? Well, most of you have in this room, but maybe it's hard to say that for yourself. Anyway, this picture is a picture of a volcano not too far from here in the Philippines. In 1991, no volcano since then has been as large as this one, but there will be larger ones coming down the road from any indication from history. And we had lots of data because it wasn't that long ago. And people are talking about getting ready for the next volcano with their instruments. The planet got cooler after this volcano for about a year, by about 0.5 degrees Celsius on average. Crops grew somewhat better because there was more indirect sunlight and less direct sunlight, because the explosion was so large that particles got lifted into the stratosphere where the residence time is months to years, rather than staying in the troposphere where particles get rained out in a week or so. So it has to be a very big volcano to have this climate effect, but in the stratosphere, which is a stable section of the atmosphere, things last a long time. So the idea that is under discussion is to induce the same stratospheric effects that a volcano induces on purpose by lofting particles into the stratosphere, which will cool the planet because they reflect sunlight, and counter the warming that the greenhouse gases are doing. And to keep doing it repetitively so that when one set of particles fall out of the stratosphere, there's new particles coming in, and in the process have a cooling effect on the planet, roughly to balance the warming effect of the greenhouse gases. You've heard that idea? It's going to be widely discussed. You have it's being discussed by philosophers and as well as by scientists. And you have a guy in this country named Clive Hamilton, who's one of the leading people engaging in this topic. Why would you want to do geoengineering in the first place? Why not just cut the greenhouse gas emissions, as we're promising ourselves to do? Maybe that's not going to be enough. Maybe we won't get to do it, and so this is regarded as a backup strategy, a plan B. Or maybe we work very hard, but the planet, whose response to climate change is still very uncertain to us, actually turns out to be full of positive feedback loops that make our efforts insufficient. And for either of those reasons, which are very different reasons, people might opt to do geoengineering. What kinds of nasty outcomes could emerge in spite of our best efforts? My colleague Steve Socolow, with whom I wrote the wedges paper that Chris mentioned at the beginning, calls these the monsters behind the door. The outcomes that represent our worst fears about positive feedback in the Earth system. I can't emphasize enough how much we will learn that we don't now know about how the Earth functions through this interrogation, this dialogue with the Earth that we're engaging in now. Change it. We are changing it. It is telling us how fast it responds. We're learning as we go. We might see a 3 meter per year, a 3 meter of sea level rise by the end of the century, where I said 1 meter was a kind of reference number. The IPCC numbers are more like half a meter. We might really see that the positive feedbacks about ice are nasty. We might see storms and droughts that kick in the way that we hadn't expected. We might see major changes in forest cover or emissions of methane from the Arctic tundra. We can't rule them out. I mean, this is a risk management problem. We do not know exactly how the planet is going to react to our emissions. That's why we have to be ready for both bad news and good news. So maybe we have two ways of thinking about geoengineering. This is just giving you a flavor of a current debate. One is save it for emergencies. Just have nothing to do with it otherwise. Be ready to use it, understand how it's used, but don't even think about putting it forward. A fellow named David Keith, who has been thinking about this a lot, says we also have to think about a second alternative. We ought to think about a second alternative, where we do a certain amount, modest amount. We say we can counter 1/3 of the warming we're doing with our greenhouse gases. Get ready for that. Get used to that. Practice what we might need to do some other time. Many people think this entire thing is ridiculous. It's just it's too much hubris. We don't understand how the planet's going to react to what we're doing with gases. We're going to set about a second strategy, as aggressive, and hope for the best. And others think that if you have the second solution, the chronic solution, you're going to build up momentum to do more. You get vested interests, and that's the slippery slope argument. Just want to raise these issues. I'm trying to give you a flavor for what some of the questions are that are being raised by this completely new problem of overwhelming the planet. How would we if we're going to manipulate the planet and make it nice for ourselves and be homocentric, we have as an analogy what's going on with genetic engineering, which goes on today to help select your progeny and the attributes of your progeny. We make them smarter. You want children who are smarter, more athletic. Versions of that. What would we do with the Earth? Well, one of the things we might do is deliberately exclude extremes. We would not want very cold winters or very warm summers, depending on where we were. We would like moderate rainfall. And so we would actually cut the tails of the distribution of experiences from climate that we have right now that might be expected. But those of you who know something about ecology, many of you know more than I do about ecology, know that many of the species of the planet survive because they find a niche in an extreme situation. Leaves blow in a very high wind to spread them far from a tree. The highest winds pull the leaf off of a tree. You try to get rid of your highest winds, you'll have a change in how trees procreate. So all over the place, we're going to have a collision if we're not careful and haven't thought ahead between human objectives, which are rather focused on comfort and convenience, and the way the Earth has been organized for 4.5 billion years. And are we losing something else if we manipulate the planet or turn the planet into a zoo around words like wildness, unpredictability? Michael Sandel has written a book about human and geoengineering, about bioengineering, changing the species, which is sounding an alarm and saying, look out, we have this unbidden aspect of our human experience might be lost. Not many people are sympathetic to that argument. I think it's an argument that hasn't been joined fully yet. So I summarize that with my current favorite philosopher's Hippocrates, who said, basically, the Hippocratic Oath basically says, do no harm. There's an elaborated form of that thought, which was developed by a doctor named Louis Lasagna in 1964, which says, I will apply for the benefit of the sick all measures that are required, avoiding those twin traps of overtreatment and therapeutic nihilism. Most of you have had some experience where someone is quite sick, and the doctor and the patient, and perhaps yourself, are part of a conversation about whether to use a very strong drug. And there's upsides and downsides. How sick is the person? How severe are the potential side effects? To me, that captures some aspects, some very problematic aspects of the way in which we have the climate problem in front of us today. So just a few more slides that are sort of summarizing what I'm saying about this. We're really talking about the collective immortality of the human species. What are we trying to do with ourselves over many generations of the human project? Very long time frames, I think, do matter to us. Although people said, suppose the world would end in a few generations calmly. The human species on the planet was to end. The human civilization experiment was over. Would that matter? And philosophers actually argue about this. But I think for many of us, it's obvious that it matters a lot. That it's important to us that we're part of an ongoing project that we see extending way into the distance. And that is one of the reasons why we find climate change important. We do care about the quality of life of humans on this planet 500 years from now. But we actually find very little guidance in thinking about this from conventional religions, which have been concerned with personal salvation. I'd like to have some of you tell me that there's a body of religious thought which does take this on. And we don't tend to think about what happens to humankind collectively in the long term. But that is the essence somehow of what the climate problem is pushing us to think about. And I imagine a new academic discipline coming forward which asks us to think systematically about the future of humanity as a whole. I call it destiny studies. And I try to imagine what the destiny studies agenda would be, or what the introductory course, Destiny Studies 101, would have as a way of a curriculum. And in two groups, this slide and the one after, I mentioned some of the topics I think Destiny Studies will include. I'd love to get into a conversation with some of you tonight and in the future about developing this idea. Cultural vitality when populations are shrinking and aging is one of the things I just mentioned earlier in this population slide. Poverty eradication, there is no reason why we can't actually accomplish something we haven't done terribly well until now. And how will that change our way of thinking about ourselves? Is there such a thing as poverty eradication, or is there always the least comfortable people at a given time are the poor who have to be dealt with? Are we doing something absolute or relative? Alternate patterns of industrialization, extremely important now that the developing world, for the most part, in the buildings they build and the cities they build, are reproducing many of the things we regard as mistakes that we are smart enough to avoid, but they're being done over and over again, versus leapfrogging, which is a word that is out there to describe industrialization that is smarter. And the whole issue of war, nuclear power, coupling to nuclear weapons, as we see now with the Iran experience. We have ways of hurting ourselves terribly on purpose not by surprise? And how do we handle those? I see all of that as part of the agenda of destiny studies, as well as more philosophical questions like the obligations to present and future distant generations. What are our obligations? How do we think about our obligations? Hydrocarbon abundance in climate change. We're not going to run out of fossil energy. We're going to have to leave some of it in the ground if we're going to have a tolerable climate, maybe most of it in the ground. How do we think about that form of self-restraint, which we've never had to impose upon ourselves before? Irreversibility and the present and the preservation of variety. Some of the things we do on the planet will make a species extinct once and forever. And can we identify those issues and systematically build capacity to deal with them? Planetary manipulation and the preservation of the wild, which is what I was just speaking about a moment ago in terms of geoengineering. And the sustenance of science is a privileged way of knowing. We have an argument in the world today about whether science is just one of many ways of thinking about the planet or some special way of thinking about the planet, refined, and about our condition in general, about our own health, refined over many centuries as a method, up for grabs in many parts of the world. Well, that's just one way of thinking about things. You have your way, I have mine. Where is this going? And are the tools of science indeed embedded in destiny studies, or is it just one of many equally valid ways of approaching subjects of this kind? Thank you very much.
Thanks, Rob. You've really, I guess, taken our minds on a bit of a journey here this evening. And to continue, I would like to welcome up to join a panel Professor Ove Gulberg, the Director of the Global Change Institute here at UQ, and Tony Wood, the Director of the Grattan Institute in Melbourne. I'm going to open the floor to questions for all of you. And so start thinking about questions, if for those of you who might have some. And as these guys get warmed up, we've got a microphone roaming, at least one. So hold fire a bit.
Sure, I better turn it on. So, Chris, what do we do next?
Okay. So we're going to invite some questions, but first of all, I'm going to just throw one question to you, and the other guys may have a response too. But one of the things you've done is challenge us to think long term, and in fact, in some of the thinking very long term. And amongst us in the room, some of us are academics, some of us are industrialists, some of us are politicians, and like some of us are led to what do we got to do to get the next grant. Others, what do we got to do to satisfy the next shareholder briefing? Others still, what do we got to do to get to the next poll and be re-elected? How do we break the kind of short-termism that has, I just think, become dominant in everything that happens in society these days and makes it really hard for us to deal with these really long-term challenges?
But I guess my point is we have to engage another part of ourselves, whether we are politicians or industrialists or academics looking for grants. We're also citizens of the world. We're citizens of a species which has a future that we can think about in an entirely new way. And another part of ourselves is that part that is looking long range. Now, changing the institutions, changing the way people behave as politicians is a different problem from engaging parts of our brain to think about this problem when we're not being politicians and academics.
Do you guys like to comment, or we just open up?
Yeah, I'd just like to add to that, because I think that's one of the things that's missing from the debate is the ethics of what we do. Now, I'm an ocean scientist, and one of the things we look at is ocean acidification. Mm-hmm. And we're doing this experiment where we know we're starting to change things at a vast scale, but it'll take 10,000 years for us to reverse that, or at least the landscape to erode into the water and to correct that pH imbalance. So what's the ethics of changing the next 300 generations of humans' lives? Associated with that are things like, well, if you're from Tuvalu or Kiribati in the Pacific, what's the ethics of us drowning your nation and you losing your culture? And I think that's a discussion we have to have, and it's the way we get back to ourselves as, rational, thinking, caring beings that I think have a chance to live on the planet long term.
The other perspective is the political economy. And I've got a cartoon that I like having on my wall, and it's got a couple sitting in their living room, and the lady of the couple is reading from the newspaper, and it says here that the Australian economy is going really well. This is a couple of years ago. And the planet's in real trouble. And the guy turns through with a glass of wine in his hand and says, well, I'm glad we live in Australia and not on the Earth. And it seems to me that typifies the way we often think about this stuff. And I think it is either uplifting or demoralising to think about this ethical question. But the world that people live in, the world that Chris referred to, is one in which the political cycle and the economic cycle and so forth dominates. So the question for me is, how do you use or misuse those elements to try and come back to this question? Because I don't know that we've got the current capacity to think about this way yet, and I don't think we've got the time to wait until we wake up to the 10,000-year challenge.
So you don't trust us?
No, to be frank.
All right.
So we have a question here, and then we have a question down the front here.
Okay. Professor, would you mind elaborating more on the trends in geoengineering? Which are most popular? Where do you see it going? Who is going to win? Will it be the acute solutions or the chronic ones? Will wealthy entrepreneurs pick it up as something that they just run with regardless of what governments decide to do? Is it going to happen or not?
Yeah, I mean, one of the ways in which this argument goes is that a well-meaning, very wealthy individual carries this out on behalf of mankind, expecting to be thanked, and can that be controlled? Or a well-meaning country on its own decides that it knows what's best for everybody else. There's that domain. My own sense is we haven't engaged this problem enough to know where it's going to go, but that until we do, we really shouldn't expect that very much will happen. The argument today is largely around whether to do research at small scale, or whether that's a slippery slope. That's what people are arguing about. For example, in my country, there's a report from the National Academy of Sciences last year. Should we do research? Should we try to put particles in the stratosphere on purpose in very small quantities to see how they coagulate, how they react with the ozone in the stratosphere? Do they harm it? A variety of questions that don't involve large manipulations. Or should we not let even that happen?
And isn't part of the problem that we don't have a good track record with the atmosphere? When you think about CFCs and so on, that the idea that we should be deliberately starting to fiddle with things at that scale? Or is that just sort of a Luddite?
I don't know. I wonder if the CFC story is actually a pretty good one. We did something inadvertent that was going to remove the ozone layer and create ultraviolet damage to human beings and the biosphere. And when as soon as we figured it out, within a very short period of time, we had changed it.
Mm.
So maybe we aren't totally hopeless.
Right, not this time. No, but you're right. I mean, one of the things about geoengineering is that you can put particles in the stratosphere and reflect light back into space and deal with the temperature issue. But going back to that issue of ocean acidification, which is a direct effect of CO2 on the ocean, that doesn't get fixed. So I suppose you'd have to be satisfied with a half fix.
Or two halves, and the other half is something entirely different.
Right.
There's a couple and then the guy behind you.
Thanks for that, Professor. It's a very good talk. I have no contribution regarding ethics for future generations, I'm afraid. I've no contribution for future ethics. On solar radiation management, An idea just occurred to me on the way down. The bulk of the ozone blocking occurs around about the mesopause, which is the sort of the region of the sort of at the top of the stratosphere where the peak amount of ozone reaction occurs. Has anyone looked at sort of injecting particles up to the so-called mesopause, like way above where the ozone is doing its work?
I don't know explicitly whether, I'm sure people have looked at questions like that. We haven't tried any of these things. There's an optimum height where you put the particles in, and I don't know the answer to that. Do you?
No, I don't know.
Just behind, no, to...
Rush out and put a patent on it.
Thanks, Professor Socolow, for your wonderful presentation. Your wedges paper, one of the great contributions that really made was to focus people on solution and realising it's not just a one answer. What do you think is the way that we need to frame the solutions and the narrative around solutions for really moving people away from the problem and focusing them on how do we achieve what we need to achieve? What can you add beyond the wedges to a narrative for solutions?
Well, the wedges paper made, which Socolow and I wrote in 2004, carried a couple of messages. One is we're ready to get going. We don't need something brand new that we can't even conceive of. It was called the already paper. We already have options. The second was it was a portfolios paper, you had to do many things at once. Not absolutely everything that might work, but many of them in parallel. And third, but muted more in the paper than in this talk tonight, is you can do all of them well and you can do all of them badly. So be really conscious about conditionality.